Ciao, ciao Stefano, benvenuto, grazie mille. Allora, Stefano è un ricercatore, security researcher per SysDig. Oggi ci parlerà di Falco più Falco Sidekick, che se ho capito bene è una soluzione di container security. Quindi sono molto
Esatto.
curioso di sentire. Dai, Stefano, la parola a te. Forza.
Ottimo, grazie. Mi sentite bene, giusto? Perfetto. I'm gonna switch in English, so since the talk will be in English. So, hi everyone, hi everybody. Welcome to this new talk regarding Falco and Falco Sidekick. Today we're gonna talk about how we can use Falco and Falco Sidekick to create a powerful response engine for Kubernetes. I'll start introducing myself. I'm Stefano, as David said, and I'm a security researcher in SysDig. Usually, I ask to the crowd if they know the monument here in the picture, but I guess anyone knows where is the monument here. So I'm from Milano, and I'm also part of the Falco community, and I'm also a Falco contributor. To start our journey today, let's just start breaking down our title into two pieces, and let's focus on the two main components we are going to cover today. So the first one is obviously Falco, and Falco is our runtime security detection engine, which detects and create alerts in case of anomalies and if something bad is going on inside our containers. So here is where the detection happens and the security alerts are generated, but we will deep dive into Falco later on in this talk. The second component is Falco Sidekick, and we can see it as our notification engine capable of forwarding events to external ecosystems and trigger the action we want, like for example, destroy the container. The goal for this talk is showing how these two components work together and how we can use an external function to create a strong Kubernetes response engine capable of executing automatic action to quickly respond and secure our environment as soon as possible in case something bad happens in our environment. And we know in cyber attacks the response timing might be fundamental and can save us from the total compromise or a massive data exfiltration. Before to start with the two components mentioned before, let's do a step back to see briefly how Kubernetes works. In a Kubernetes environment, we have a master node where the kube API server is placed. We know when the user wants to execute commands on a cluster using the command line kubectl, the user is actually interacting with the kube API server, and the cluster might have more than one worker node, and in here is where the containers are actually created and deployed. In each worker node, the kubelet is deployed to talk with the master and receive and get the different actions from the kube API server. So I won't go too much in details on the Kubernetes components available by default in masters and worker nodes, but this is a super high level on how a Kubernetes cluster works. We started already talking about why we need a Kubernetes response engine, and as we said, the very first reason is to have a faster incident detection and a faster reaction times, since timing, as we said, is truly fundamental for us. We need also to keep in mind that Kubernetes clusters span a large number of nodes and containers deployment, so it might be pretty challenging managing or investigating or even correlating events in such big environments. So this might mean hours or days lost in operational stuff, delaying even more our incident response actions. and the final results would be a completely inefficient reaction time in case of a security events. Having an automated response means also having a more scalable solution, and it could make life way easier when you need to implement automatic actions or even a playbook of actions. So by now I should have already almost convinced you that it sounds like pretty useful solution for security purposes, but let's leave the discussion for the end of this talk. We can now start with the first component, and as often happens, we need to start from the past and talk about some history about Falco and its progress till today. So Falco is a runtime security project originally created by Cisco back in 2016. In 2018, Falco has been donated to the CNCF, and it became the first CNCF runtime security project. The next natural step would be to make it a graduated project. Right now, is in the incubation level, and the next step will be the graduated project like Kubernetes. But we will see what is going to happen in the future. In these years, also a huge community raised behind Falco, and the community is also currently running the project and make the project always better with always new Falco rules to enhance the detection as well. Recently has been also presented the new plugin approach for Falco, which could let Falco works with cloud logs and the opportunity to develop also plugins to work with different log sources for web servers or also different applications. So we said Falco is our runtime security project, but right now the question you might have is why focusing on runtime security to create a response engine? And the answer to this question, let me use the physical security alarm metaphor. So we usually talk in security about prevention intrusion, and this is where we usually focus our main attention. We know that fences, door locks, perimeter sensor around the house are really super important to know what to be aware and what is going on outside, and if someone is actually trying to break in. We are all familiar with the security mechanism used for prevention intrusion, like password, MFA mechanism, firewall. And if we go specifically in container world, we talk about image scanning or vulnerability scanning for container registry or pipeline and so on. And basically, what we are doing is creating a big wall around our container or our environment. But the real question here is it enough? And the answer is obviously no. And we can already see the problems with this approach. So let's assume that a robber is able to break into our house and steal all our money, for instance. We actually don't know what is currently going on inside our house or inside our container, and if someone is trying to take our stuff out of the safe. This because with this approach, we have no visibility on the inside, and our focus so far was just to keep the bad guys outside, avoiding with basically all our strength to break in. And another key point is that in security, not all is actually well known and already seen, so we know how to secure our environment from. And if we think about it, 0 days are the main example here that the whole approach is actually lacking of something. So let's move a bit our focus on the inside and what we can actually do to have a better visibility of what is going on inside our house or inside our containers. So we could actually install some motion sensor and interior cameras into our house to see what is going on in case someone was able to break in, his moves, and what is actually stealing or breaking. And in security terms, in this way, we could be able to see all the attack path and get alerted if something malicious is going on. In addition, we could also be aware of what has been stolen, and we know that in IT security isn't that easy to find out compared to the physical security, where it's pretty obvious to find out, unfortunately. In addition, it's also useful for audit purposes to know basically who did what, or what exactly happened and when did it happen, and so on. So to implement the detection intrusion in container world, we can use Falco and this detection engine to find runtime anomalies and create security alerts over malicious behaviors. And I think we can all agree this is the approach we must take. So don't get me wrong, I'm not saying that focusing on prevention intrusion is just a waste of time and money, but as we know, security works in layers. And what I'm suggesting here is combining Falco with prevention tools or techniques to create what we call the defensive in-depth approach. The problem could be how we can actually do that, but luckily for us, Falco knows how to do it for us, so that's fine. So Falco allows us to monitor the inside and monitor what is actually going on in our containers, in our Linux machine, in Kubernetes clusters, and put together mainly two resources, so syscalls and Kubernetes audit logs. The first question you might have now might be, wait a minute, why we use syscalls? And the answer is pretty simple. If we think about how syscall works, anything you do in all the layers generates a lot of syscalls, from run a binary to open a connection or read or write a file. So system calls are how a program enters to the kernel to perform actions, and as you can imagine, all this information can be used for different purposes. The Falco purpose is to use these events for security and create runtime detection. This is possible thanks to the Falco rules available in the Falco engine, and I'm going to show you an example later on in this talk. So as we said before, Falco isn't just all about syscalls, but Falco can receive and use Kubernetes audit logs. And the truth is that syscalls are as important as Kubernetes audit logs, since we can answer different questions like what happened in a Kubernetes cluster, who initiated an attack, or when it started, and so on. So using these events, it's possible to create Falco rules over Kubernetes audit logs to generate also security alerts. And I think you can start understanding one of the real strength of Falco. So Falco is able to put together syscalls and Kubernetes audit logs and create a strong detection on both sides. So we talked already pretty a lot about Falco, but let's try to deep dive into how it works. As we said before, that all starts with from syscalls in kernel module, and since all the programs run in the host or in containers generate syscall, we can use Falcos to bring the syscall from the kernel space to the user space. So since the kernel module needs high privileges, Falcos also support eBPF probe, which runs in a restricted environment without requiring high privileges to run. And thanks to the rim buffer, we can move, as I said, the syscall from the kernel space to the user space, where we can find also two main libraries, so libscap, libsinsp, and of course our Falco engine, which is the heart of Falco. The libraries do all the activities like collecting the syscall, generate the capture, and in particular, the libsync library perform the event parsing and enrich the events with additional information coming from container runtime and Kubernetes data. And of course, all this context information could be also used in the Falco rules to create detection over this information. And as we said before, besides Cisco's Falco support Kubernetes audit logs, and in the user space, we can also find, as we said, the Falco engine, where the real detection happens and where the Falco rules are in place and are generating security events. As we have already understood and as I've already said, the Falco engine and the Falco rules are the art of Falco. And here we have an example of Falco rules to detect a terminal shell spawned in a container. And you can see here the structure with condition, output, the priority, and also tags, which can be used to customize the rules that we want to activate in Falco. We can also define lists and macros, which can be used in rule condition to make them easier and more readable. And Falco rules support logical operators, and also there are also other different operators, like the operator in if we need to work with lists, and operators like start with and end with if we need to match strings and work with strings. The Falco rule set is collected in YAML files, and you can easily add your custom rules just by editing those files. And it's pretty a straightforward process. So I suggest all of you to start playing with Falco and start creating new rules for yourself, and also share them with the Falco community as well. Here are some of the rules already available in Falco mapped on the Mitre attack framework for containers. And as we can see, the Falco rule set already available covers a lot of TTPs, but of course there are also other use cases related to Kubernetes audit logs, and also use cases related to new CVs or crypto miners attack and so on. So there is a constant work done by the Falco community to check, update, or implement new rules basically every day. So we need also to keep in mind though that the rules already available are pretty general, since they have to fit all the users and all the customers. And of course, I suggest to start playing with Falco and customizing your own rules based on your needs and your environment to avoid false positive and reduce the noise you may have introducing and enabling some specific rules available out of the box. So we know that to have a better detection, we need to tune our own detection tailored for our own environment and basically for the use case that we are really interested to monitor. Otherwise, we will have a lot of false positive and we will miss what is really important. Let's move now our focus to the second component we talked before, and it is Falco Sidekick. We talked about Falco so far, and we understood that Falco basically is an engine which generates security alerts based on Falco rules. But what we can do with those alerts, and of course, we can decide to keep them locally and just have a look at those events. But what about having, for example, a nice UI where you can filter those events or group them by severity, or even start investigating from there? And even more important, why can we forward this event to somewhere else and perform proactive action with these alerts? And Falco Sidekick indeed provide a nice UI for Falco, and I'm going to show you the UI during the demo. And Falco Sidekick also allowed us to forward the Falco alerts to a lot of different ecosystems. We can see here Falco can be integrated with a bunch of different systems and a bunch of different for different purposes. And you may want to receive the alert directly on Slack, for instance, or forward the event in the log management, like Splunk, where you might have already your detection dashboard that you are checking every day for security misbehaviors. And in alternative, you can use those events for metrics or alerting with PagerDuty or even more. So, but as you can imagine, today we are going to focus our attention to the function as a service, which are our major component to create our response engine. And function as a service, due to their nature to receive events and perform a series of automated actions, are exactly what we were looking for. We have our event source, which is Falco and Falco Sidekick, generating and forwarding events. And these events can trigger a function as a service or a workflow and perform actions proactively, in this case in Kubernetes. And the action for Kubernetes might be various, and it depends, of course, on the rule triggered and the alert severity, and of course on the response that we want to achieve. For instance, if we see the rule that you have seen before related to the terminal shell opening a container, let's say in production, you may want to stop the container right away. Instead, if you see, for example, rules like right below etc or right below dev, you may want to respond in a different way, since the behavior is not malicious per se, and you may want to proceed with the event validation before to decide which action you want to perform. But if we stop here for a minute and we summarize what we have said so far, we have our runtime security detection engine, which is Falco. We have also Falco Sidekick, which permit us to integrate the Falco detection and send the alert to external ecosystem, as we have said before. And we also know now that there are functions as a service available that receive events as an input and perform actions on Kubernetes. And so, and the action might be create, delete, or update the pods, or even more. But if we put all the pieces together, we got exactly what we wanted. And here is what we wanted to achieve. So using function as a service like kubeless or openfaas or Argo, it's possible to create a Kubernetes response engine capable of performing proactive action in case of anomalies or malicious behavior in our environment. And that was the goal that we have, right? So it's now demo time on what we discussed before. And for this demo, we are going to use Falco Sidekick, and Argo as our magic function. And here are the components deployed for the demo and how they interact each others. I also added the links for the various components in case you want to start playing with them. And as I said, we are going to use Argo to create our workflow, but let's just spend a couple of words on Argo and its component that we are going to use today. So Argo is another CNCF project, and we are going to use mainly two Argo components, so Argo events and Argo workflow. Argo event is a event-driven workflow automation framework for Kubernetes, and it basically allows us to automate action and trigger Kubernetes objects. And in our case, Argo events, we will receive the events from Falco Sidekick and push them into the event bus. And in particular, we are going to use two Argo events objects during the demo, so event sources and sensor, and we will see in a minute how they works. Argo workflow instead is the workflow engine used to orchestrate jobs in Kubernetes, and here is where are defined and where we define and where we model the workflows, and in each step of the workflow is actually a separate container. In this case, we're going to use Argo workflow to listen to the event bus and trigger the actions, and then trigger the workflow in case the criteria we defined are matched. So let's start with the demo and the goal. Let's just set the goal for this demo, and the goal is to deploy a Kubernetes response engine which will react in case of a crypto miners attack or crypto miner activities are detected in our environment. So we are simulating the scenario where an attacker is able to hack the application that we have in our container, and is also able to download the miner into the container and run it. For this demo, we are going to use detection over network connection to malicious IPs and port, and we found these IPs and ports related to crypto miners during our resources. But of course, this is just a way you can use Falco to detect crypto miners. Other ways actually are already covered by default Falco rules, and if you are interested to this specific use case, I suggest all of you to have a look at those rules that are already available for Falco. In this specific case, the action that we want to trigger in the scenario is to destroy the pod in case connection related to crypto miners are detected, since it's a behavior that we want to stop as soon as possible from our environment. And in the same way, we could perform also other actions. For instance, apply network policy into Kubernetes to block ingress or egress for network connection and so on. So let's start now with the demo, and we can start just checking what we have in our environment. And in this case, we have Argo events and Falco namespaces. So let's deep dive into the Argo events, and let's see the event source object that we have deployed. The first object is an event source object, and in here we define the webhook. So there is a webhook defined that is listening on port 12,000 in this case with endpoint /Falco, and this is one of the main components that we are going to use for Argo. Let's see also the service. There is, as we said, a service related to the events, to the event, or related to the object that you have seen, listening on port 12,000. Let's also have a look at the sensors already in place. So we have a minor IOC sensor deployed, and in this case, we are going to match the Falco rule triggered. In this case, the name is detect outbound connection to IOC miners found. So in this case, if this rule is going to be triggered, the sensor is going to push the event into the bus and trigger the workflow. So as we have said before, we need also an Argo workflow in place to say what action to trigger. So let's have a look at the Argo workflow available in our environment. So in this case, there is the delete pod template. So let's have a look what it does. And in this case, we are using this image. This is an image provided by the Falco community, and in this case, we've just customized the action. We can see here the image created, and on the bottom we can see the delete pod function. And in this case, we are getting the pod name, the namespace, and this is the action that we want to trigger. So in this case, as we said, we want to terminating and deleting the pod as soon as we see some crypto miners activities in our environment. So this is the Falco rules. There are two lists, one related to crypto miners IP and one related to the ports that we found to be used by crypto miners. And in this case, we are getting just the connect Cisco, and we are matching the IPs, and we are checking the IPs and the ports in the connection. And of course, the priority is set to critical, since we, as I said, we need to stop the behavior right away. So as we said at the beginning, let's suppose that the Alpine container contains our application that has been compromised. So let's open a shell in the container and see here we can see the crypto miners that have been deployed by the attackers, and we can run it and see what is going to happen when it has been executed. So let's check now the status on the container, and we can see that the status is terminated. So the workflow has been correctly triggered, and we can see now all the details from Argo workflow. And so this is the Argo UI, where you can check if actually the Argo workflow has been triggered correctly or not. In this case, let's just find the workflow that has been triggered. So we can find here that has been triggered 43 seconds ago. In this case, we can also see all the information related to the image that we used, the log triggered. And if you go back to the main logs, we can also see the event. So in this case, we can see the event that is coming from Falco Sidekick, and also the pod name, so Alpine, and the namespace, so default, and the Falco rule triggered. In this case, the rule that we have seen before, so detect outbound connection to IOC miners, and also the action that has been triggered. So in this case, deleting the pod Alpine for in the namespace default. And here is the Falco Sidekick UI. In here, there are already some graphics available out of the box when you install and you deploy the Falco Sidekick container. From the UI, you can also filter by the container ID or the pod name, and or also using the severity. So in case we want to filter just the events with the severity critical or whatever. Here in the events, we have all the events triggered in our environment, but of course you can also filter by container ID or container name. In this case, those are the alerts that have been generated, and the first one is the one that we have triggered during the demo. So as I said, there are already dashboard ready to use, and you can also filter by time range or see if a specific rule has been triggered in our environment, in which container it has been triggered, and so on, with the criticality, and also filter by priorities and criticalities. So this is the main power of Falco Sidekick. So Falco Sidekick provides a nice UI for Falco, which is the detection engine. But as we have seen, we can also use Falco Sidekick to send our alerts to other ecosystem and trigger actions or just forward the events for further investigation. All we have seen today regarding Falco and Falco Sidekick is also thanks to the Falco community, which is working hard to make the old Falco project better and always more powerful with always new Falco rules in case of new CVs are out or in case of new attacks are discovered. And getting started with Falco is super easy, and I suggest all of you to give it a go and join the Falco community and start contributing to Falco, creating new rules. You can also reach the maintainers on Falco Slack and ask for help if you need, or even propose new changes to the project and suggest new stuff in the community channel as well. So that's it from me. Let's start the Q&A session if we have any questions for me.
Allora, in realtà una domanda e poi una ce l'ho io. Allora, una domanda che è arrivata era quali pensi che siano diciamo, i punti di forza di questa soluzione rispetto ad altre soluzioni simili, no? Perché ce ne sono un po' diverse che fanno cose simili. Volevo, appunto, la domanda era quali erano i punti di forza. In poche parole, forse ti tradurrei come convinceresti qualcuno a migrare da un'altra soluzione a questa qui, dicendogli però la mia fa anche questo e quest'altro. E poi invece la domanda che ho io, aspetta, la domanda che ho io, la seconda domanda è se per caso questa soluzione fa anche dei controlli tipo i controlli del CIS.
Ok, allora
Okay.
parto con la prima domanda. Allora, la forza di Falco, a parte che, vabbè, come si è detto, è un tool open source, chiunque può prendere e usarlo, è molto flessibile e soprattutto dà un sacco di informazioni sugli ambienti Kubernetes. Quindi usando Kubernetes ti permette di creare detection e Falco rules su praticamente qualunque cosa ed è molto flessibile. Quello che è stato fatto con Falco Sidekick dalla community Falco è anche la possibilità, appunto, come abbiamo visto, di forwardare questi event dove vogliamo, quindi ci dà praticamente flessibilità di fare qualunque cosa. Quindi si può usare per semplicemente forwardarli verso Splunk nel caso in cui uno ha già o un'azienda ha già la propria dashboard fatte, diciamo, oppure creare, come abbiamo fatto, proprio un response engine vero e proprio e quindi fare una serie di proactive actions. La vera forza di Falco è che lavora di fatto con le syscalls, quindi praticamente vedi qualunque cosa e puoi creare regole su di fatto qualunque cosa. E oltretutto ti permette, come abbiamo visto, di mettere assieme anche i Kubernetes Audit logs e creare regole anche nel caso in cui venga creato un nuovo container, nel caso in cui venga creato un nuovo service account o a new role cluster o qualunque altra cosa. Quindi questa è, diciamo, la vera forza di Falco, perché hai visibilità su qualunque cosa, creando ovviamente le apposite rule per Falco, poi di fatto creare detection su qualunque cosa.
Okay.
E riguardo invece la parte di CIS, ovviamente si può fare, no, attualmente non è coperta questa parte qui perché cioè dipende di fatto come si usa Falco, nel senso si usa Falco per creare detection su sicurezza vera e propria, quindi nel caso in cui ci sono cose diciamo critical o security issues o vere e proprie security issues, quindi vogliamo avere un alert o un alert per ogni problema di sicurezza che abbiamo. Altrimenti si può usare anche Falco per più dal punto di vista auditing, quindi per forwardare tutta una serie di informazioni che si vogliono avere sul nostro environment, come abbiamo detto, perché poi dopo si vogliono usare presso CM o altre soluzioni per usare queste informazioni da correlare con ancora altre informazioni. Quindi si può ovviamente fare, quello che si cerca di fare su Falco è di non implementare cose troppo noisy, altrimenti ovviamente sappiamo benissimo che tool di sicurezza che offrono troppa visibilità e su cose troppo noisy alla fine va a finire che non se ne viene a capo e diventano praticamente inutili. Quindi si cerca di trovare un buon trade-off tra l'usabilità e l'essere troppo noisy, ecco.
Ok, perfetto. Grazie mille Stefano, molto, molto
Grazie a voi,
interessante.
grazie a voi. Ciao a tutti, buona giornata.
Ciao, ciao Stefano.